All right, so today we're going to talk a little bit about doing this stuff on paper. So we'll start at the top. So one of the things we're starting to recognize is that we're applying all these transformations to different functions. And it's important to understand the shapes of the parent functions. So for example, this is absolute value, looks like a V. And has a lot of the aspects of the parabola, and that is symmetrical on both sides. Here's x squared, y equals x squared, our beloved parabola. This is x cubed, and then this is the square root of x. And all of our graphs get their shape from their function. So for example, this one right here is going to be a parabola. This is going to be an absolute value bar, so it's going to be like that. This is square root function, so that's going to look, the general shape is going to look like that. And then this one is cubed, so the general shape of it is going to look like that. And then we can start applying all of our transformations to this. Now some questions that we have is, what 2 points do they all have in common? Well, they all have the vertex 0, 0 and then 1, 1. And we're going to be using that relationship up 1 over 1 to kind of sketch all these graphs. But remember too, you can always go back to plugging things in. And then which point changes depending on whether it is an odd or an even function. Now we haven't talked about odd and even functions, but this is an even function, it's x squared. This is an odd function, it's x cubed. Lines are actually odd functions as well, in that they're raised to an odd power and they look kind of like this. And the thing that changes is this point here. So we have up 1 over 1, and we also have down 1, back 1 on odd functions. They end up down here. On even functions, they end up here, like this one. Okay. So now let's graph some of these functions. So I'm going to start here, and I can see that my vertex is the point 6, 3. So I'm going to start there at 6, 3. And then I have a vertical stretch of 2, of negative 2, a vertical stretch of 2, and a vertical flip. Okay, so I'm going to go. So normally, right, my parabola goes up 1 over 1, but instead my vertical stretch is going to go up 1 over 1, up 2, and because it's negative, it's going to go over 1, down 2, over 1, down 2, and then probably the best strategy is to just plug in some points. So I'm going to plug in 8 because it's 2 away, right? And so I'm going to say a of 8 equals negative 2 times 8 minus 6 squared plus 3. 8 minus 6 is 2, squared is 4. And negative 2 times 4 is negative 8, plus 3 is negative 5. So a of 8 equals negative 5. So there's that point, and then I can mirror that across, and then I can draw my line. Okay. So there's A. Next, let's look at B of x. So this one is an absolute value, so it's going to be a V, and it's going to be located at negative 4, positive 3, right there. And I have a stretch of 1/2. So in other words, it's going to go over 1, up 1/2, and then over 2, up 1. And it's going to do that in both directions, and I just need to draw my little V. Now if you're not sure about that, I can go ahead and plug in this value here, negative 2, and it doesn't matter which value I plug in, I just know that that one's going to give me a nice number. So negative 2 plus 4 is 2. The absolute value of 2 is 2, times 1/2 is 1, plus 3 is 4. So there it is. I plugged in a negative 2, I got out a 4. Now, this one is square root of x, so it looks like the square root sign, but it has a horizontal reflection, okay? So my vertex is at 0, 0, right? And then normally it goes up 1 over 1, up over 4, up 2, kind of goes like this. But all of it's reflected back this way. So it's going to go up 1, back 1, and over 4, up 2. Now, with square root functions, I'm always going to think about what square roots do I know, and then I'm going to look at the difference between the vertex and the next point, and I'm going to want that difference to be 1 and 4, 9, and so on, so that I get nice numbers out of it. Okay, so this is C of x. This is B of x. All right, last one. My vertex is at -3, -2, and I have a vertical stretch of -1. So I'm going to go to -3, -2. Now at this point, probably, now normally this function goes like this. And because it has that vertical flip, that means that this point is going to come down here, and this point is going to go up here. Now that gets kind of confusing, so it might just be easy to pick points on either side of this x value. So I'm going to find d of -2. I'm just going to plug that into my function. -2 plus 3 is 1. Is -1. -1, or is +1. 1 cubed is +1. -1 times +1 is -1. So d of -2 equals -3. So that's that point right there. Okay. Now I can find, let's find one on the other side. Let's find d of let's find d of -4. So in other words, something over here. -4 plus 3 is -1. -1 cubed is -1 times -1 is +1. So I plugged in -4 and I got out -1. So that's that point right there. Now I'm going to plug in -5. -5 plus 3 is -2 cubed is -8 times -1 is +8 minus 2 equals +6. So as I move up here, I plugged in -5 and I got out +6. So that's that point right there. And I can sketch my graph coming through my vertex and then shooting down off my graph. Looks something like that. Okay. So that is d of x. Anyway, I hope this is helpful, and that's kind of the example problems. And we'll stop this here.